All right, so today we're going to be talking about Chapter 4, Lesson 4, Scientific Notation. So a number is going to be represented in scientific notation when it's looking like a number times some power of 10. So for example, if I have A, where A is a number, and what's very important here this is a number between 1 and 10. That's very, very important. If we want to look at it like this, 1 is less than or equal to A is less than 10. Essentially, A has to be a one-digit number. It can have decimals after it, but it has to be a one-digit number previous to the decimal point. And then what it looks like is either a dot or an X for times, and then some power of 10, where n is any integer. It can even be 0. So, for example, if I have this here. This is written in scientific notation. This is proper scientific notation. There's a one-digit number before the decimal point and some numbers after the decimal point. And it's written with a power of 10 where the exponent is 4. So this is good. This is not good. Yes, we will see that those two will evaluate to the same number, but this is not okay because the 35 is not a one-digit number. It does not fall between 1 and 10. Now, when we start to evaluate this, so let's look at 3.5 times 10 to the 4th. This number here, the exponent, this tells me how many times the decimal point moves. So we say it's the number of places the decimal moves. If it is a positive number, it moves to the right. If it is a negative number, it moves to the left. Essentially, a positive exponent represents a number that's very large, and a negative exponent represents a number that's very small. So let's go through some examples. 3 times 10 to the 5th. This 5 right here tells me that I need to move my decimal point 5 places, and because it's a positive number, I'm going to move it to the right. So I start off with 3. My decimal point is really right here. So 1, 2, 3, 4, 5. So my decimal point is now here. I have all these empty spaces, so I need to fill them in with zeros. So 3 times 10 to the 5th is 300,000. Letter B, 4.395 times 10 to the 4th. Again, a positive exponent, which means I'm going to move it to the right. And because it's 4, I move it 4 places. So my decimal point is right after the 4, where it should be, because there needs to be a one-digit number before the decimal point. It moves 1, 2, 3, 4 places. So now my decimal is right here. The 3 takes up this first place, the 9 in the second, the 5 in the third, but I have nothing in the 4th, so I need to make it a 0. So this number is 43,950. Letter C. I'm now going to move it to the left because my exponent is a negative number, and it'll move 6 places. So I have 6.79. Go 1, 2, 3, 4, 5, 6. So my decimal point is now right here. All these empty spaces need to be filled in with zeros. And there needs to be one here as well. So now this number is 0.000000679. So notice how on positive exponents, the numbers are relatively large, and on a negative exponent, this is an incredibly small number. So example 2, let's now start evaluating or expressing each of these numbers in scientific notation. So again, my exponent or my decimal point is here. I need my number to be between 1 and 10. So I'm going to start moving my decimal point. So I'm simply going to put a times 10. Here's one place, but I still have 80,000 in front of it. Here's two places, that's still 8,000. Three places, that's still 800. Four places is 80. Five places is 8. That's good, because 8 falls between 1 and 10. So it's 8. And I moved it 5 places, so it is an exponent of 5. The original number is a large number, so I make sure that my exponent is positive. There's not a 0 in front of the decimal point. In fact, there's 800,000 in front of the decimal point. Letter B, there is a 0 in front of the decimal point now, so this is going to be a times 10 to the negative exponent. Again, I want to move this so my number in front of the decimal point is between 1 and 10. So I move it one place, but I still have a 0 in front. I move it a second place, now I have a 1 in front. So that's where I need my decimal point to stop. I moved it two places, so it's a negative 2 exponent. And I have 1.19. All right, example 3, it says if you could ride your bike 200 meters per second, and that's about 447 or 450 miles per hour, so very fast, it would take about 1.92 times 10 to the 6 seconds to ride to the moon. Now, is it more appropriate to represent that number as 1.96 times 10 to the 6 seconds, or is it more appropriate to do 22.2 days? And I would argue that this one is the more important number, or the more appropriate number. One, because this is an incredibly large number, and it's in small units. Seconds are kind of hard to understand as far as time goes, because we have 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day. So that's a lot of seconds just in one day. Where 22.2 days, that's something very easy to comprehend. So 22.2 days is more appropriate because, one, it has the larger units. And two, it's easier to imagine. Again, 1.92 times 10 to the 6th is a very difficult and large number to kind of comprehend. So days is much more appropriate. Now, before we get to example 4, we have to talk about how we compare and order numbers in scientific notation. So we kind of pretend like we're doing this in alphabetical order. But we look first, we look at the exponent. So the larger the exponent, bigger the number. And then we look at the number out front. So, in example 4, it says the diameters of Neptune, Saturn, and Uranus are listed in the table below. Order the planets from greatest to least. Again, greatest to least. So, first thing we're going to look at is the exponents. So here's an exponent of 4, here's an exponent of 5, so Saturn has a larger diameter because 5 is larger than 4. and Uranus is also 4. So far, Saturn is the largest, has the greatest diameter. So Saturn is the largest. So we're going to kind of X that one out so we know that we've done that one. Next one, we're going to look at the next greatest. So both of these exponents have an exponent of 4. So now we look at the numbers out front. Here's a 4. Here's a 5. 5 is greater than 4. So Uranus would be next. And then that would leave Neptune for last. All right, that is the end of Lesson 4. If you have any questions, please let me know.